Hello world, my name is Francisco. I am from Cuernavaca City, Mexico. The title of my project is Soundwave. First of all, let's talk a little bit about sound. As you may know, sound is a wave of pressure that travels through the air. Like any wave, it is oscillatory in nature, meaning that it is a process that repeats periodically. The properties of sound, such as loudness, tone, or timbre, can be described by its wave properties. The most fundamental sound is a sine wave. The time it takes a sound wave to complete one oscillation, that is, its frequency, determines its pitch or tone. A sine wave of 440 Hz sounds like this. If we double the frequency, it now sounds like this. The height between its highest and lowest points, that is, its amplitude, determines its loudness. The larger its amplitude, the louder it sounds. One very strange property of sound, in my opinion, is timbre, which determines how sound, sounds. I find it somewhat analogous to flavor, as if it were the taste of a sound. Timbre determines whether a flute sounds like a flute, or whether a violin sounds like a violin. And perhaps even stranger is that this property is determined by the shape of the wave. We have already heard how a sine wave sounds. Let's now listen to a triangular wave. And this is the sound of a square wave of the same tone. Any waveform can be constructed from the sum of simple sine waves. For instance, a square wave can be formed by summing sine waves whose frequency is an odd multiple of a base frequency and whose amplitude is divided by the same odd number. By the way, this process of adding sine waves together to create a new wave is referred to as Fourier series. The sine waves that add up to the final wave are called harmonics if their frequency is an integer multiple of the base frequency, or partials if they're not. In short, any waveform can be described as a sum of harmonics and partials. Going back to the main topic of this video, I made a program to synthesize sound waves using a list of harmonics and partials and their respective amplitude. I made the program in C and called it Soundwave. The source code consists of a file called soundwave.c, where the main function is defined, and a few other files that contain helper functions. I also added a makefile to quickly compile the program using the make command. The program expects three arguments: a base frequency, a CSV file that contains a list of harmonics, more on this later, and a name for the audio file that will be created. The program reads the CSV file and produces a WAV file that contains 1 second of the synthesized sound. Let's create a simple sine wave of 880 Hz. Now, let me explain you about the CSV file. The file must contain one or more rows of two numbers separated by a comma. The first number represents the harmonic, or partial, and the other represents its amplitude relative to the others. Let's see the file I used to synthesize the sine wave. It consists of only one row, which instructs the program to use the first harmonic and set its amplitude to 1. Now let's synthesize something more complex. Here you can see the first 50 harmonics that constitute a square wave. As I explained earlier, a square wave is made of the sum of odd harmonics. Here I set the first harmonic with an amplitude of 1, then the third harmonic with an amplitude of 1/3, next the fifth harmonic with an amplitude of 1/5, and so on and so forth. If we now use this file to synthesize a sound, this is the result we get. Well, here's my explanation of these simple command line programs that synthesizes sound waves. Thanks for watching.